Today we're going to be conducting an analysis of simulated urine samples to investigate normal and abnormal levels of metabolic indicators in urine. So we're going to be using 10 mils of each of the samples, and we're going to be looking at pH today and also specific gravity, and we're going to be looking at abnormal protein and glucose levels. And for our samples today we have low, normal, and high, and then we also have unknown A and unknown B. And you want to get ready to pause the video. As soon as the samples come back in a view, they're going to zoom in, and you're going to want to open up the urinalysis assignment that's posted in the lab folder. And for your first question in that assignment, what you want to do is write down the color of the 5 different samples. And then you'll use some information from a table that's posted to answer the rest of that question. And we're going to be using pH test strips to measure the pH of the 5 samples. These will be labeled to keep them sorted out, and I'm also labeling some test strips that are going to be used to indicate the presence of glucose and protein in the samples. Alright, we're going to go ahead and get started doing the pH tests. Pretty straightforward. Just going to dip a piece of pH indicator paper into each of the samples. And of course, pH is the negative log of the hydrogen ion concentration in the sample. The lower the pH value, the higher the concentration of hydrogen ions in the sample. And each whole number value on the pH scale indicates a tenfold difference in the concentration of free hydrogen ions. So for instance, if we look at a sample that's at a pH of 4 and a sample that's at a pH of 3, the pH 3 sample will have a tenfold increase in the number of hydrogen ions. Now I'm starting to do the protein and glucose test. So we have a little green square on each test strip and a little yellow square. A color change in the green square is going to indicate a positive test for glucose, whereas a color change in the yellow square will indicate a positive test for protein. Now, glucose shouldn't typically be detected in normal urine. Its presence is usually going to indicate diabetes mellitus, which is a severe metabolic disorder that's going to result in elevated blood glucose levels. And if blood glucose levels are too elevated, the kidney will not be able to reabsorb all the glucose, and some of it will end up in the urine. And regarding protein, a very small amount of protein is normally present in urine, but any actual changes in the color of the protein test strip is going to indicate an elevated level of protein in the urine. Now, our test strip might just go from yellow to a slightly different yellow, and that isn't necessarily a positive test, but changing from yellow to maybe a pale green would be a positive test. And now you're going to want to get ready to pause the video. The results of the pH tests are going to appear on the screen. You're going to want to use the color chart provided to estimate the pH based on the color of the test strip. You want to record the pH values on the urinalysis assignment, question number 2. And then next we're going to look at the protein and glucose results. These are going to be addressed in questions 3 and 4 in the urinalysis assignment. And remember that color change in the green square will indicate a positive result for glucose, and color change in the yellow square will indicate the presence of elevated protein. And for reference, there's an unused test strip at the bottom. You can use it to compare its colors with those of the strips that were used in the test. And next we're going to test the specific gravity of our 5 samples. Each of our samples will be poured into this cylinder, and then we're going to use a hydrometer to measure the specific gravity of the sample. The buoyancy of this hydrometer in the sample is going to indicate the density of the solution relative to pure water, which has a specific gravity of 1. And the scale that's located on the side of the hydrometer is how we're going to determine the specific gravity of the sample. More solute in the sample will result in a higher specific gravity. And the presence of alcohol in the sample can lower the reading as well. So to read the hydrometer, you're going to want to see where the meniscus of the sample intersects with the scale. So taking a closer look at the scale, where we see the 10, that actually indicates 1.010, 30 would indicate 1.030. There are 5 hash marks in between each of those primary markings so that we can record the specific gravity at 3 places past the decimal. And you'll want to pause the video as each of the results comes into view. You'll also want to record the data in the urinalysis assignment question number 5.